Okay, so this question is on a Poisson distribution. So in maths, right, there are for statistics, there are different kind of probability distributions. Okay, so it simply tells you like what is the frequency. It's actually a distribution of what is the frequency when of something happening, some event happening. So for example, okay, if in a classroom their students are scoring 3 marks, 5 marks, 10 marks, 20 marks and 30 marks for an exam, and this is there are 5 of them, 6 of them, and 8 of them for this, and 2 of them for this, and 1 of them for this. So this is actually a probability it's a frequency it's a distribution. All right, and by this we know like what is the probability of a person getting 3 marks, and let's say if I pick any randomly pick a student from the class, what is the chance of me getting a student with 3 marks, so on and so forth. So but probability Poisson distribution is a type of distribution that deals with like for example in 1 hour what is the probability that 3 accidents happen. If I have statistics about accidents happening in the past, then I could come up with a parameter, this one, and use this parameter to estimate the probability of something happening in a number of times in the future. So if you want to know more about probability distribution, so you should read up on statistical distributions. There are three types of distributions that are very common. We call it the normal, the Poisson, and the binomial distributions. So you could read out on them, and you can get this book and read the chapter on the Poisson distribution before you attempt this question. So I'm going to go through this. It's a pretty simple question. So let X denote the number of typographical errors on a single page of lecture notes. Okay, so assume that X has a Poisson distribution with parameter lambda equals to 1. That means in a single page of lecture notes, alright, the on average there is 1 typo error on one page of the lecture notes. So we want to calculate the probability that there's at least 1 error on a randomly chosen page. So at least 1 error means greater or equals to 1, could be 1, just 1, or more than 1. So I'll find the probability that the number of errors is greater or equals to 1. Right, so the number of errors follows a Poisson distribution. This is the symbol for Poisson distribution, and this number inside the bracket is this lambda equals to 1. So this is lambda equals to 1. Right, so or sometimes they call it the mean or the variance of the distribution. Alright, for the Poisson distribution, the variance of x is equals to the mu, or the expectation of x. That is just for Poisson distribution only. Alright, and okay, so we go on to do this. So because Poisson distribution is the number of times or even is a discrete. So is the number of times something happen is a discrete. It can be 1, 2, 3, 4, 5, 6, and so on and so forth. The minimum number it can take is 0. That means something did not happen at all. So it cannot be less than 1. So for example, it cannot be less than 0. Sorry, it can be less than 1, but it cannot be less than 0, because you can't have a negative number of typo errors on a page. It doesn't make any sense. Or you can't have negative minus 1 accidents on the road doesn't make sense in real life. So Poisson distribution is for things that happen 0, 1, 2, 3, 4, 5, 6 discrete number of times. Alright, so this here for Poisson distribution, where for x equals certain number, right, it has this formula. Okay, let's say the Poisson distribution has a parameter of this mu. So the formula, this is my exponential, right, and to a power of negative this parameter and multiplied by this parameter to the power of this number here r over the r factorial. R factorial is just equals to 1 times 2 times 3 times all the way to r minus 1 times r, so on and so forth. So let's say 4 factorial is just 1 times 2 times 3 times 4. Okay, so then what is 0 factorial? 0 factorial is equals to 1. Okay, surprisingly, right, but 0 factorial is equals to 1. So then we make use of this formula because greater or equals to 1, so numbers are like this, right, the possible numbers, and so on and so forth. I want greater or equals to 1 means I want all of this, and all the probability when you add all the possible cases, you get equals to 1. So I'll take 1 minus the probability that it is 0 will give me the probability that it is greater or equals to 1. So 1 minus probability that there's no typo error will give me the probability that there is at least one typo error. So then I just apply the formula over here because my lambda is 1, so I'll just substitute this 1 here, right? So this mu, this lambda, and this is lambda, same. So there will be 1, and so e minus 1 to the power of this number 0, then divided by 0 factorial. Okay, using this, so 0 is the number from here. So then 1 minus this, so I will end up with this, and that would be the answer to this question. So there is a probability of 0.63212 that there's at least one error on a randomly chosen page, and that's it.